Hi YouTubers. For this video, I'll ask you to read carefully the description content. I'm doing this with one hand. We're doing a first approximation of power loss in a commercial supercap, 2.75 volt rating, 30 farads capacitance. And I'm setting this up to show some of my students fundamental features of an electronic load device. I'm using, as I've mentioned in so many of my videos, a ZKE Tech battery tester electronic load. If you're going to do cycles, so you can do single tests, auto test, that's for power, and cycle tests, make certain that you get model EBC A10H. A20H will not have cycles, and I think for essentially the same price, you surely want to get A10H. I hope they're still on the market. I buy these at Amazon. They're very reliable. Okay, so what you're seeing up here, look carefully at my cycles. I've completed or at least stopped after 3 cycles. And you see the Coulombic ratios for charge discharge. The first one I throw out. See how the capacity is 0.001 for the first charge. So I run 2 or 3 or more. I have it down for 10, but I only did 3 for the demo. And you want to see that 0.011 DCC and 0.011 CCV. In order to do what I'm going to show you next. Now, this is important. It's an approximation of power loss in a supercap. We are designing composite electrodes. We're testing out so-called water in deep eutectic solvents, WIDEs, and your equivalent series resistance is a very important parameter in energy storage. And that would be resistance in the system made by the manufacturer. And you take into account the electrolyte, the electrodes, the temperature, many parameters. I'll put it in description. Now, this is what I want to show you. As soon as I began the discharge in the 3rd step, you have to be quick on the trigger here. And as soon as you get that voltage drop, just about to here, compare it to this one, the second. That's your initial voltage drop when you start to draw current. You go to Tools, Resistance Test. Now I'm using 500 milliamps. So we'll type in 500, and we want to get the milliohms. (1586), 1.586 ohms. Now that is going to give us power loss approximation. And I will put this in the description. And when you take into account that power loss is the square of your current draw, 500 milliamps, 0.5 amp squared, that gives you 0.25, times your ohms, 1.586. That will give you your power loss. I'm running about 0.284 watts to 0.2885 watts for just a few cycles. And that is the power loss due to heat. Now also with ESR, it depends on definitely the manufacturer's specs and the age of the supercap, and what type of current draw in cycles discharges, charge, discharge. There are many parameters involved, but this is an excellent feature in this inexpensive and reliable E-load device. And in the description, I will put all of this information. So if you are a home researcher or you're teaching undergrads, getting them involved in introductory aspects of energy storage, in my case, supercaps, this is what I show my students. Now, I'm retired. I'm emeritus at my school, but I'm continuing to do research with selected students. So this is a very important parameter, equivalent series resistance. And I thank you so much for watching. If you have any questions, just send me an email. As always, thank you. Bye for now.